Today, we'll be taking a look into how do we solve a system of equations by the method of graphing, but this time, one of the graphs is going to be given to you. And the main idea here is that to solve a system of equations, we can graph both equations and find the interception. And it is important to remember that the interception is the solution of the system of equation. Now, this is something that we discussed in the previous lesson, but here is going to be a little bit different in the sense that you're going to be given a graph, but you're only going to be given one of the graphs and the equation for the other. And it is our task to find the solution to that system of equations here. So let's get started. It says here, let's use the following information to find the solution to the given system of equations. Okay, so let's see, what is it they're being given us here? It says fx is given by the graph below. Okay, so we don't know exactly what fx is, but we do know that this is fx. Like this equation is fx, is being given here. Fx is given by the graph below. Okay, so this is fx. And then they're going to call g of x to be x plus 2. Okay, and now this is what we're trying to answer here. What is the solution for fx equals g of x? Now, let's actually pause and let's actually try to understand what this means here. What this means is when are the two equations equal to each other? So, when are the two equations equal to each other? So, when are the two equations equal to each other? Well, let's find out. So, what do we do here? Well, we know that f of x has been given here. And g of x, they don't give us a graph, but they do give us the equation. So what we can do here is, let's graph it. So let's clear that, second quit. Y equals, and let's put the equation that we want to find out, x plus 2. So we have x plus 2. Oops. So we have x plus 2. We know that if we graph it, it's going to be a line that goes something like this, but we want to be precise, so we press second graph. So here's the table values. Let's choose some points. So here we have that the first point is negative 2 comma 0. So negative 1, negative 2 comma 0. So that's 1 point. Another point is negative 1 comma 1. So negative 1 comma 1, which is about right here. Another point is 0 comma 2. 0 comma 2. I'm sorry, negative 1 comma 1 is not there, but over here. So negative 1 comma 1, it's right here. We got 3 points. So let's just connect them because we already know that it's a line. So let's just connect them here. Oops, let's make that red. So we got that here. And let's just be exact. Yeah, that's fair. All right, so, and again, don't forget to label it. So the red graph here, this is g of x equals x plus 2. Okay. So now, can we answer the question now? When are the two equations equal to each other? Well, pretty much they're asking us when do they intercept, and you can see clearly that at this point this is the interception, or what we're going to call our solution here. So now the solution set, it means at what coordinate points do we have a solution here. So we have at negative 1 comma 1. So the solution set here is negative 1 1, and that's the only solution. So let's just write that down here. So the solution to the system of equation is just 1 point, and that's negative 1 comma 1. Okay, let's see another example now. So it says, what is the solution to the system of equation y equals x squared plus x squared minus 4 and y equals fx, where f of x is given by the graph below. Okay, so f of x is given by this graph. So let's just label it. This is f of x. We don't know what it is, but they're telling you that it's been given. All right, cool. But what exactly are we trying to answer here? It says, what is the solution to the system equation y equals x squared minus 4 and y equals f of x? So pretty much this is the question we're trying to answer here. So when does y equal f of x? This is what we're trying to answer here. But at least we know f of x is this graph. But we also know that y is being given by x squared minus 4. So let's graph y equals x squared minus 4, because this is what we were trying to answer. When does y equals f of x? F of x is here. Let's graph y on top of it, and let's see when they're equal to each other, or let's see where they intercept. So second quit, let's put the equation that we want to graph here, x squared minus 4. So we're going to have x squared minus 4. Second table, let's get the table values. Let's get some of those points out here. So we're going to get negative 2 comma 0. So we're going to get negative 2 comma 0. So that's about right here. Oops. Negative 1 comma negative 3. So negative 1 comma negative 3, which is somewhere around here. 0 comma negative 4. So 0 comma negative 4 is somewhere around here. 1 comma negative 3. So we got 1 comma negative 3, which is about right here. And let's just take another point. Let's take 2 comma 0. So 2 comma 0 is around here. All right, so let's connect those points. Let's just extend those lines. So let's just extend them. All right, perfect. Let's just label it. This is y equals x squared minus 4. So let's see, let's stop and let's see. Can we answer the question already? When does y equals f of x? Remember, this is f of x. We already graphed y. So when are they equal to each other? So that's going to be at about this point, and that's going to be at about this point. Okay, so these 2 points here, this is where they intersect. So these 2 points here, these are our solutions. So all we gotta do now is just write them in what we're gonna call the solution set. The solution set is just a set, is just a collection of things. But because we're gonna call the solution set, it's pretty much the collection of all the solutions. So we have one solution here, one solution here. So let's write it down. What would be the coordinate point for this? Let's just estimate. That was gonna be negative 2 comma 0.25, give and take. And how about this other point? That'll be 2 to the right. Yeah, it's still 0.25. So then you got positive 2 comma 0.25. Now here's the deal, or here's the flaw when you try to solve a system of equations by graphing. There's times where you're not going to get the exact solution, and you're going to have to kind of estimate the solution here. That is a big flaw when it comes to solving system of equations by graphing. And you just saw it here, but it gives us a pretty good estimate here. So this is the solution set. We got 2 solutions, negative 2 comma 0.25. And yeah, there's a little mistake here. It's not 0.25, but negative 0.25, because it's right here. Sorry about that. This is negative 0.25. Because it is on the y-axis and we're going down, so that's negative 0.25. All right, so we got 2 solutions. That is a solution set, but let's actually write it out. Here, what are my solutions? So my solutions Here they're going to be -2, comma, -0.25. Let's put the negative in front of it. So -0.25. And also 2, comma, -0.25. All right. So now that we have here, the most important question is to understand what exactly are they asking us. It's just a word problem, but it's something that you have seen on the previous video here. The main idea here is to identify that this is exactly what they were asking us. When are the two equations equal to each other? In order to figure that out, you plug them in, you graph them, and you see where they touch each other. That was the main idea for this lesson here. So now, here's an entrance ticket. Given the following graph, what is the solution to the following system of equations here?